arithmetic, and I said, what is the absolute value of 3? You would say just 3. If I said the absolute value of negative 3, you would also just say 3. So you've been trained that absolute value bars mean the positive of that number. Just take it out of the absolute value signs, make it positive. Or it's a distance from 0. How far is it from 0? So the first thing you see in your note packets is the absolute value of what equals 3. So we're kind of doing it in reverse, an algebraic equation. What can we plug in for x that makes this true? And this is why there's two answers. The absolute value of 3 is 3, and the absolute value of negative 3 is 3. So x equals 3 and negative 3. All right, extending that to the second example, I can't do this one off the top of my head. I will need to write some steps down. But it's the same idea. Whatever would make this equal 7, the absolute value of 7 is 7, and whatever makes that quantity negative 7's absolute value is 7. So I'll need to write that down and do that work. What makes this equal 7? What makes that quantity equal negative 7? Do a little equation solving. And you find there are two answers to that as well. 5/4 will work, and negative 9/4 will work. And again, you could verify that. Plug those back in. Both of those answers make this a true statement. Okay, so your method is going to be drop the absolute value bar, set it equal to 7 and negative 7. Now, if it starts out as a negative, like number 3, there's something up with that. The absolute value of something equal to negative 6 makes no sense. You know, you can't put anything in for x and then take its absolute value and equal to negative. It's flawed, right? From the beginning, that question made no sense. So you just say no solution. So it needs to have a positive number here before it makes sense to write the two statements. Another thing to watch out for is you need to isolate your absolute values before you proceed. So if you have some extra stuff added or multiplied or around the absolute value, move it across first. Simplify it so this is alone. So bring the 2 across, and then do what we did on this last problem. Make sure you do that. You'll get one answer right and one answer wrong if you don't isolate first. So you must do this to get it right completely. So then you say what makes that 1, what makes that negative 1, and then solve and get negative 6, and negative 8. Number 5, similar. Again, just want you to notice that number 5 you had to isolate. It looked like it may be a flawed problem, but once it was isolated, it was okay. You know, like I wouldn't want you to look at that and say, she said if there's a negative sign here, just put no solution. Remember, you have to isolate it first. So bring the 5 across, and then all is well. Now it is workable. So isolate first, right? Then set it to 2 and negative 2. And then solve those two parts. All right, before I do the inequality part, just jump over a little bit. I want to show you the absolute equal to absolute method. So, the absolute value of 7 is equal to the absolute value of 7, or the absolute value of negative 7 is equal to the absolute value of 7. Let's think about those two statements. Two numbers that are the same quantity of their absolute values are the same, that's a true statement. Or if they were opposites of each other, that's a true statement. So if you're asked to do a problem like this, example 1, where you have two absolute values expressions, here's how you're going to proceed on those. An absolute equal to an absolute. There's two possibilities. either these are the same numbers, the same quantity, like 7 and 7 or -7 and -7, whatever it is. Maybe these are the same two quantities. Or they're opposites of one another. One's a positive, one's a negative of the other. The way we get that written out algebraically to solve is we say, is there a value that makes this equal this? That's equation solving. What would make this equal to that? So drop your absolute values, see if there's something that makes those two sides equivalent. Also, is there a value that makes those opposites of one another? So just one side times by a negative. Doesn't matter which side you do. So I'm going to do the first. I'm going to times side 1 by -1. And then side 2, leave it alone. So either side, put a -1 on it and leave the other side alone. That will give you your two answers. Now sometimes this equations just won't work out. There is no solution, but this is how you would find any possible solutions. And we get one. If k is -7/3, if I plug that in for k, those two numbers are equivalent, and so they're absolute values. Other problem, distribute the negative sign to the one side only. Then do your equation solving. And we see that if k is -1/7, the two sides will have opposite signs, and therefore absolutes will be equivalent. So again, two answers. Okay, any questions on that? All right, so now I want to quickly tell you about the inequalities because I know I'm running out of time. So go back over to the example where we left off, inequality problems. They're very similar, okay? So we're going to have a similar set of steps. Not a whole bunch more I need to tell you here. But instead of just being equal to 3, it's equal to an interval, right? So if you have a greater than or less than an inequality, you get an interval answer. On the number line, you can show that or an interval notation. So name all the numbers whose absolute value is greater than 3. The obvious part of it is things greater than 3, like 4, 5, 6, 7, a million, so on. Notice no line under it, it's over parentheses. So obviously things greater than 3, their absolute values are still greater than 3. But also greater than less than -3, like -4, -5, those absolute values would be positive and therefore be greater than 3. So the other way, less than -3, check it out, plug in numbers over here, absolute value positive then, and it is greater than 3. So what happens on the inequalities is you get this statement, x is greater than 3, kind of write it like it would be with the inequality or the absolute value drop. And then also write it with this turned around, less than, and a negative sign. So greater than 3, that's this part, and turn it around for a less than and a -3. Those are your two intervals. And that's how we're going to do the less thans and the greater thans. This little trick will work. So notice number 2. Same thing is true with number 2. We say x is less than 3, and x, what did I say to do? Flip this, greater than, and put a negative. So greater than -3. So you're going to remember, flip the inequality and change the sign. So it looks like this, less than 3, so this way of 3, but greater than at -3, so this way. So it makes a little closed interval. The less thans will be a closed interval between -3 and 3, where this is at. Okay, let's try another, number 3. So here's one that I couldn't do in my head. I would need the steps. Remember, step 1 is to isolate it. If necessary, throw that 1 across the line before you make any decisions. That makes that 5. I am out of time. Then write your two statements. 2 minus 7m greater than 5. 2 minus 7m less than negative 5. You'll solve those two parts. I know I'm out of time, so I'll just say then you solve those two parts and you'd get your two answers you're looking for. Just another quick thing. Number 4 and 5 are your special cases. On number 4 and 5, they're kind of flawed, like we had an earlier example. You can't have an absolute that's less than a negative, so it's flawed. No solution to that. Whereas on number 5, if your absolute is greater than a negative, that's always true. So watch the negative situations. If this is isolated and you have a negative number, it's one of those you need to think about. If it's greater than a negative, that's always true, from negative infinity to positive. Okay, so I think that's everything I needed to tell you to kind of get